I'm from Team 3 and today I'm going to presentation about CPU scheduling simulator with Java final project of operating system course. In this project, we hope to implement the file scheduling algorithm such as for converter, shortage offers, SOT, round robin, and MLFQ. And we will use Java framework, Java programming language. And second, we will simulate our process into the Gantt chart with the color. And the third one, we will do comparative analysis. So we will compare the algorithm performance between FCFS, FCFS, SOT, round robin, and multi-level queue. And the last one, we will do our project in interactive GUI. So you will see it in the next slide. And the tool and technology that we have used. So we have used Java programming language, and we have used GitHub to do collaboration coding, VS Code to writing code, and the last one is Telegram to have communication with my team member. And we also use many library in Java. So the first one is java.awt. So we use it to handle GUI element. And the second one is java.io. IO means input and output. And the third one is java.ot. So it basically the collective framework with the data structure of Java, java.touch, java.time, java.swing, and java.swing.table. So it's basically manage the table model for display the data. And here's our project structure. So we basically have the first one a bin. So bin basically is the compile bytecode. That means it's the class file after we compile. And the second one is source slash algorithm. Source that means source code, and algorithm that means our algorithm. So in there we have implement FCFS for converter, FJS, sorted job first, SOT, sorted remain time, round robin, and a molecule, and also the best scheduler interface there. And the last one, and the next one is source slash model. It basically the data layer. We write the process.java, Gantt entry, schedule result. So it basically for data representation. And the next one is source slash simulation. That means we basically use it for run the logic, run our logic. And the next one is source slash UI. UI means user interface. That means we implement the main window, our Gantt chart view, our result table, and also the input panel. And this one is the same, and we will move to a data. In the data, we will store the sample process.csv. Because our GUI, we also can import the process into our app, not just input by our hand. We also can import from the file. And the last one is auth. Okay, so here's our project structure that we implement. Next, we will talk about the flowchart in each algorithm. Okay, so the first flowchart is for converter. So for converter, the algorithm is very simple. We sort the process by arrival time. That means the process that arrives first will run first. Okay. So the second algorithm, we run it by sort by burst time, and we pick the shortest. You can see here when the program start, it will have the process arrive, and we will know the burst time and add it to the ready queue. And after that, we will sort by burst time, and we will pick the shortest. After that, and and for the third one is round robin. So the round robin is the algorithm that fair and simple. We the first we need to set the time quantum q. Okay, so q can be any number, any integer number, and then our process will run in that quantum number. Let's say we set q equal to 4. That means one process can only run 4 slots. After that, it will react back to the back queue till our process finish. And the last one is preemptive algorithm. We call it shortest remain time, or we can call it preemptive SJS. So you can see when we start the program, and okay, the process will arrive, we will know the burst time, and it will add to ready queue. After that, it will pick the process that have the shortest birth time, and after that is have any process that shorter than that. We will pick that minimum auto resource. Okay, I will example for you. Let's say let's say the arrival time one, we have one process that have 9. After that, in the two we have the process that have burst time 8. So in the first, our algorithm will run this one, and then in the second one we will see that one process is 8. So we will check, is 8 lower than 9? Okay, is it true? We will run that process. After all the process is end, we can end our program. But is in the second is 10. Okay, so 10, is it lower than 9? No, it's not lower than 9. So we will not run it. We will run this 9 till complete. So here is the four algorithm work. And for the multi-level queue, since we implement five algorithm, and for the multi-level queue, I haven't add the flowchart yet. Okay, here's our multi-level queue. So in our multi-level queue, we have three queue. So the first queue is round robin, and the second queue is round robin as well. So the first queue is have the highest priority, and the second queue is medium priority, and the third queue is lowest priority. We use for come first serve. Okay, so after the process end, we will end our program. You will understand this more in our demo. And here is our result. We have implemented GUI1. You can see in our first come first serve result, you can add the process here, or you can import, and you can choose the algorithm, and you can run the simulation here. After we run simulation, you will see the Gantt chart. You also see the average waiting time and turnaround time. Okay, so this one is the same, this one the same, this one the same. Okay, you can see clear, right? Here's our process, our algorithm, our Gantt chart, and our symmetric average waiting time, average turnaround time. So here's our team member. We have 3 team member. First one is Koisei Maricot. She implement SOT and run robin. My name is Juan Sovisa. I'm implement MLFQ and design the GUI interface. And Kijang Jessica, she implement for Converser and SJS algorithm. Next, we will move to the demo.
Greeting teacher, my name is Kujan Jessica. I am from Team 3 Group 1. So today I will be presenting about the CPU scheduling project, final project. And I will be present on the only two algorithms, which is first come first serve, also known as FCFS, and SGF, which is known as the shortest job first. So here is my algorithm. So I'm not gonna explain the whole coding, but I will explain the core algorithm in each process, each algorithm. So starting with the first come first serve algorithm. So here is the main core algorithm. So first I will be set the current time to 0. This current time means like I will loop into the process. So I will be compare the arrival time of each process. So if the arrival time is smaller, I will add it into the Gantt chart. And I will do the same this until I end all the process. So since first come first serve is the non-preemptive, which is each process will be executed until it is finished, it will move to another process. So there will be no set amount of time or quantum time that is set and move to another process, or there is no interruption in each process. So and then here's the algorithm of calculating the response time, waiting time, turnaround time, and calculating the average of each of the time. So starting with the response time. So response times is the time that we calculate how fast does each process responds. So it is the time between the starting point and the time where the process is in the ready queue. So here's how we calculate it with the starting time and the time that it is ready in the waiting queue. And then we have the turnaround time. So turnaround time is like the whole process from start to the end, including the waiting time. And the waiting time is like the turnaround time. We take the turnaround time minus the burst time. So we can see the waiting time, which is like, so in the turnaround time is the whole process including the waiting. So in order to find the waiting, we take the turnaround time minus the burst time. We will see the waiting time. How much does each process waiting? And the burst time is the whole time of process execution, but we don't count the waiting time. So waiting time and burst time together will equal to one turnaround time. So this is the algorithm, and in order to calculate the average of it, we must like sum all each of them in each process and divide it with the total number of each process. So now I'm gonna demo. So in here is my GUI interface of calculating the process. So I'm gonna give for process first is process ID number 1 with arrival time 0 and 5 burst time 5, and then I will add it. The second ID arrival time 1, arrival time 1, burst time 2. Here are my process, and now I'm gonna run the simulation. Okay, so as you can see that in first come first serve, so the process with the shortest arrival time, we will serve it first in the Gantt chart. And since it is the non-preemptive, so it will execute until the process is finished. It will move to the another process. So as we can see in here, the process ID 1 with the shortest with the first arrival time. So we put it in the Gantt chart, and it takes 5 block of burst time to finish the whole process. So from 0 to 5 is for 1. So once it finished, it will move to 2, which is the next shortest arrival time, and 2 need only 3 blocks. So we can see here, and then we have 3. So we need 6 blocks of it. So in here is for process 3, and lastly is for process 4. So, and here is the average waiting time, turnaround time, response time, and the total execution time. So next I will be presenting about the SJF, which is the shortest job first. So this shortest job first is also a non-preemptive. So it will execute until the process ends. It will be moved to another one. So here is the main algorithm of the shortest job first. So I'm not gonna explain the full process, but this is the main algorithm that we need to understand, also the core of it.
Afternoon, teacher. So my name is Koisei Marakat. Today I'm going to explain the algorithm SRT. So as for the general idea is that the code implements the short remaining time, which is SRT, and it's always, which means it's always selects the process with the smallest remaining execution time, and it can also interrupt the current process if a shorter one arrive. So this is the main like the general idea of SRT. So right now I'm going to explain for the main core process. So for this one is line 23, list process queues equal new array this, which means you can input the arrival time, bus time, and also process ID, and the output will be a scheduled result, Gantt chart, waiting time, turnaround time, and a response time and average. So this is input and output, as I said. And for this one is also a key idea, which is it is the heart of the code span for most here. So for this, while q dark stream dark animage equal to p that is completed, it means that the algorithm run time step by time step until the all process are finished. So it run until all process are finished. And as for number 4, which is for process p q, this is like it's only consider process that already arrived, and it's pick the one with the smallest remaining time. So this is how this is how it's work. It's only consider the process that already arrived, and it's only pick the remaining time. Up next, if base equal null, it means if no process, which means if no process has arrived yet, the CPU is idle, and it's jumped to the next arrival time, and so which means no process arrived, its CPU is idle, and so that is the concept. And after this, it is the line 66, if current not equal best. So it means if a shorter job appears, it switch immediately and it save previous process in Gantt chart. So which means it is the most important concept as well. And up next is this one. this one is the base dot set remaining time, base dot get remaining time minus 1, which means run process for one time until it's reduced remaining time. That's why we minus 1. Again, a run process for one time, and then one time unit, then it's reduced one remaining time. For this, if it is a completion process, if base dot remaining time equal to 0, which means the process is finished, and then record end time. Then record end time is like this. So if the remaining time equals 0, process finish, and then it's record end time. And up next is the process calculate, like it's called calculate metric. So for this, for weight algorithm, we do end time minus arrival time minus bus time, and then we got wait time. For turnaround, we got end time minus arrival time, and then we got turnaround. And for the last one, if we take start minus arrival time, and then we got response. So this is all for the algorithm of SRT. So now let's we gonna move on to the GUI. So this is our team GUI, CPU scheduling algorithm simulator. So as you can see here, this is what I input here. So this is the process ID. So I put 1, process 1, I got arrival zone 0, bus 5, priority zone, and then process ID 2, I got arrival 1, bus 3, process ID 3, arrival 2, bus 6, and process ID 4, I got arrival time 3, and bus time is 8. So each process arrives at different time and require a certain amount of CPU time. And for the SRT, unlike the FCFS, SRT can interrupt a running process if a shorter job arrives. So now let me walk through the executions why we got this one like this. And we also got the algorithm of SRT, which we have average waiting time, turnaround, response, and execution time. So for time 0, as for time 0, only P1 is available, so it ran. And for time 1, P2 arrived at bus 3, P1 remaining 4, and then P2 is shorter, so which means P1 is interrupted. So which means this is preemption. And as for time 1 to 4, P2 run until completions, and time 4 it choose the best remain, like it choose the shortest remaining. So as you know that P1 equal 4, P3 6, P4 is 8. So the shortest remaining one is 4, so it run P1, and then it's continue P3, and then it's continue P4. So which means the Gantt chart shows how the CPU switch between process, unlike FCFS, and you can see the interruptions where a shortest job replaced the current one. So you can see that here we calculate the average waiting time, average turnaround, and response, and then total execution time. So for waiting time it means how long process wait. So we got 5 here. How long the process wait, and then turnaround, it's total time of the system. And for response time, it's the first time it's get CPU, and this is the total execute time, it's 22. So this is all for SLT. And the most important feature of SLT is preemptions. The CPU always switch to the shortest remaining job. So this is it for the SLT algorithm.
More about MLFQ algorithm that you can see. So I will not add the process by hand because my team member have added. So I will load it from the file. You can see this one is load from file, and we need to find our file. So our file is in this PC. Okay, in so we say one, and we will go to OS CPU scheduling Team3, go to data, and we will import our sample process. And you can see it will load up our process. We have 10 process with different burst time, different arrival time. And then we can run our simulation, and then our simulation will we visualize the Gantt chart, and you can see our Gantt chart, and also our simulation will also give the metric. We have average waiting time, turnaround time, response time, and total executing time. So you can see our process have give the visualize the Gantt chart and main metric. And also we can import our result. You can see in here is our result button, and then we can, okay, let's say import it into desktop, and let's say result dot csv. Okay, just say result, and this result will go to the desktop. Okay, so you can see our result have go to the desktop. Okay, we can open, you can see our report, CPU schedule result, algorithm MLFQ, performance metric, procession detail, and our Gantt chart. And here's our code that we implement at MLFQ. So here's our algorithm that we have implement. So basically we have three main queue. The first queue is round robin, which is the high priority one. The second queue is round robin 2, and the third queue is we use for come first serve, the lowest priority one. Thank you for your time and consideration, and we have finished our CPU scheduling simulator. Thank you.